Presentation is being done by myself, Brian Crouch, and Sean McManamy. We're evaluating the paper, Evaluating an Active Learning Approach to Teaching Introductory Statistics, a Classroom Workbook Approach, written in 2011 by Carlson and Winquist. So in coming up with this paper, both Sean and I teach in an in flipped classroom environment this semester, so we're using a lot of active learning. Initially, we were going to use the topic active learning techniques in algebra, but we couldn't really find a lot of papers on that, so we made the decision to expand the topic to active learning approaches in mathematics. And we ended up coming up with this paper that's on statistics. Realistically, this paper had 3 research questions we wanted to look at. First was the simple, how effective is a semester-long active learning statistics curriculum that differed significantly from single-day activities previously found ineffective by Weltman and Whiteside? So, a quick background on what Weltman and Whiteside's paper had in there, and this is just coming from the Carlson and Winquist paper that we reviewed. Basically, the study that they looked at involved doing a bunch of single-day activities that didn't really build on each other too well. It was basically one day, and then the next day you're doing something completely different, not scaffolding on what you already know. So that was found to be ineffective, but they wanted to see if taking a different approach might be a little bit more effective. They also had the question of how does this active learning curriculum impact students' attitudes towards statistics, which was something that they were able to do with a pre-test and a post-test on student attitudes, which Sean will talk a little bit more about later. And then, does this active learning environment have a detrimental effect on the performance of high GPA students? In some of the previous studies that had been done, it had been shown that high GPA students did worse in the active learning environment than they did in the more traditional classroom. So those are the 3 questions we want to look at, and now Sean will tell you about these statistical methods that they used.
Alright, so what they ended up doing was doing surveys conducted first before they actually started the class and after they finished the class. So it's not dealing with the actual straight grades or anything like that. But what they were using was called the Survey of Attitudes Towards Statistics, which is a survey that gives attitudes about statistics. The 36 afterwards tells you how many questions there are. Overall, there were 6 separate categories that these questions are broken down into. Some dealing with students' perceived perception of how difficult the class was, how statistics were, how easy it was to do, whether they like it or dislike it, how much work they think they have to put into it. So there were 6 different categories for that. So the survey was given to 4 experimental classes taught by the 2 people who ran the experiment. There were also comparison classes, which were spread out through different universities of approximately the same size. Unfortunately, the comparison classrooms had very little in the way of structure that was able to be implemented and looked at closely. So they weren't able to do any comparison of grades or things like those because they weren't sure how other classes were getting taught. So it focused primarily on just the survey. Now some of the variables. This looks kind of sparse. But basic variables is which class they're in. So you could be in the regular class or the experimental class. And even again, the regular classes, there were 20 separate comparison classes, which they had no idea about what was going on in any of them, except for standard curriculum. Which instructor you had? We had the Carlson and Winquist. One of these instructors taught 3 of the classes. One of them taught 1 of the experimental classes. And then you have all the instructors for comparisons. Again, since an instructor is teaching multiple sections, there's the time factor as well. So he can't be teaching at 8 a.m. for every single one of his classes because he is only so many days a week that he's capable of doing so. So you have that factor. And the other factor they do end up looking at was the high GPA students versus the low GPA students a little bit. There was not too much of analysis on those, but it was there. Now for the analysis, what they ended up doing was looking at the distributions of the ranks on the surveys. So all the surveys were numerically evaluated from 1 to 5. So they did a distribution check to see if they were normally distributed on the different categories instead of on each question individually. So for 4 of the 6 categories, they were found to be non-normal, which means they had to do non-parametric analysis, which they announced this. Now, the one issue I have is for the 2 sets that were normally distributed, they still did non-parametric analysis, which is viable, but they also did parametric analysis, but did not show any of the parametric results that they had. So that was one issue they had that I noticed. Another thing they did was for the pre-test and for the post-test, they compared the experimental classes to the comparison classes. For the pre-test, they didn't end up finding any significant difference on the survey results between the experimental and the comparison class, which is what they were hoping for, considering that will make sure that the comparison classes are a good comparison for the experimental sections. Now on the post-test, they looked at the changes from the initial to the final results, and they did find significant differences for the experimental classes. So by going through all this analysis, they were able to find some results. Now I'm going to turn it back over to Brian to figure out things that we have learned.
So one of the things that Sean alluded to was that the students who experienced that workbook approach had positive changes in their attitudes towards statistics, while some of the results in there showed the students in the comparison group actually had a negative change in their attitude towards statistics, basically saying they were less confident in their ability with statistics after taking the course than they were prior to taking it, which is highly interesting. They also noted that these positive GPA or positive changes were positively correlated both with their final exam performance in the course, which you would expect an A student to be a little bit more confident leaving a course than a student that got a C, and also with the student GPA. And in the little bit of research that they looked at with the high versus low GPA, they found that unlike in the Weltman and Whiteside's study, that this approach didn't produce detrimental effects for the higher GPA students. So that concludes our presentation.